Good morning. Happy Monday. It was a tiring week last week, man, with all the kernel dev. I spent most of yesterday just doing a whole bunch of lifting, kind of reposing a bit. We're gonna try to get some more dev in today. I think we're pretty close to done. Well, not done fully, but like, I think we're very close to having an end-to-end working, useful prototype. It's always one more thing, man. There's always one more thing. And mechanics. Alright, so where last we left our hero. Welcome, term. I think we had the working Ford kernel, right? This does not need to be this wide. Do like this. Let's see where we have this. We're gonna start on the RMS kernel today. I think if we can get this done and we fix the multi-threading thing from Peru, I think we should be able to have something reasonably performant as a starting point. RL, they are, as far as I know, they're just doing LLM stuff, man. Okay. So yeah, this is where we left off. We have a correct forward kernel, a runnable backward kernel, but the backward kernel is wrong. And I had like, I believe this was the math of it. Of course, the obnoxious thing with this, right, is, yeah, the obnoxious thing is, of course, I don't know if this is correct. Multi-objective. You can already use this for multi-objective RL. Or goal-conditioned RL is usually how you formulate it. Not hard either. Okay, so this is the formulation that we have. We're free for 15 minutes now. Oh yeah, let me look at drone stuff real quick. Thank you. I told Sam and Finn to bug me if I forgot to look at the drone PR. And here they are dutifully bugging me for forgetting to look at the drone PR. Discord? Sorry, lol. What? Did you want to chat about it, or did you just want me to look at it? You got all these PRs. Oh, okay, sure. That's what you meant. That's no problem. Let me get off of this. Unilab. So, we got... I mean, this is gonna look like 2 files deleted and then merged back. I mostly want to see what the new code looks like. Okay, so there is somehow you got it to be a single env. Oh, actually, I remember I had a tough time doing this because I tried to make it a single env originally and I couldn't get it to work as, like, I couldn't get it to work cleanly as one env. Bird. Who is that? That Alex or someone? Cool. Not great at multitask. Get there from this code soon. I see. But does it train, like, can you train it single task? Like, this doesn't break racing or break, you know, the swarm tasks if you train individually, right? Ring buffer. I like how you have a ring buffer that's literally a buffer for rings. At the same time. Cool. Perfect if you train separate. Nice. Oh, yeah, if anybody is looking for, like, an example of how to write a good environment, look at the code that these two write. Like, the drone M stuff that they've done is really solid. See if I have any nits. I kind of need to look at the Python file first to see what you did. Okay, wait, how is this working then? Because... how you specify the training task? I don't see anywhere that the train task is getting specified, right? I see num drones, I see max rings. What do they do that is good? They write code that doesn't make my eyes bleed, man. Like, look at this. We'll go over it in a second, as soon as I can figure out what they're doing with, Okay, guys, can you tell me where you are specifying the task that you're training on? Because you say it's perfect if you train separate, but, like, where do you specify that? Just in C right now. Okay. So if it's just in the C, then you don't have a way to specify. Oh, like hard coded in the .h file, you mean? You definitely want to be able to configure that from the .py, guys. So please do that. Even if it's just passing like a task index, like an int index, like anything like that is fine as long as there's something. Let's go to, let me see. So it's drone lib. And then they just made a render. Cool, that's fine. So let me make sure. Oh, and then they have tasks. This is like a big enough PR that I sort of just want to go look at the, go look from here. .c, .h, and then you get 1, 2, 3, 4. I think this is reasonable for an M this size. Yes, you can. What is crit? You can start with pure Python. You're going to quickly figure out that it's actually not that hard to just write C, though. Dynamic task reward. That's kind of funny. You let them go out of bounds and then you bounce them. Orbit. Okay, so these were like the targets I had from the... Yeah, I made a bunch of these tasks, I remember. So you pulled these out. This is fine. And then you did... I want to see what the new drone lib looks like. So this is now a... that's not bad. Has the login here. We have the drone. A bunch of vector math. Here is RK4. Okay. Step. Just one RK4 step. That rings. Okay, cool. So this this looks similar to before, but then drone.h is now going to be A very simple thing. Cool. Okay, this is not bad then. I was originally wondering why you had broken up, like, I was worried that the project had gotten way too large, because you were breaking up the project into a bunch of different files. I think realistically there isn't a huge need to have done that, but it's not terrible either way. Because the thing is, like, that drone lib really isn't a general purpose library. You really wouldn't use that file directly in anything that is not this env the way it's written. So I don't typically see the reason of breaking stuff up when you're not going to include the code somewhere else anyways. But it doesn't look like that has become an excuse to write twice as much code as you need. So that's totally fine. Same thing with render. Render file looked really short. Task file looked really short. So that's like generally all fine. I'm curious as to what you did on specification of tasks. So I see this does get a task. It looks to me like you are still doing train on everything here. Just looking tasks. Yeah, so I understand splitting out the tasks in that sense. I don't know why you split out DroneLib, but I think it's fine. Because, like, the only reason that I really, like, the main reason at the very least that I tend not to split up files is because people tend to use it as an excuse to write way more code than they need, right? If you're staring at one block of 1,500 lines of code in a file and you know that you only need 700 lines of code, you know that you're dumb. But if you have it split across 3 files, it's way easier to, like, not realize you have way more code than you need. But because you have more code than you need, like, you haven't run afoul of that anyways, so I don't really care if you want to break stuff up, provided that the main thing of not having too much code is satisfied, and this looks like a reasonable amount of code for this project. I don't know what you've done with the task specifications, though, because I remember when I did this, I couldn't get the drones to work cleanly on all the tasks simultaneously, which is why I had it split up originally. And it looks like you have this set up to train on all the tasks simultaneously, which, if you could get this to work, would be fine. But I think given that it currently doesn't train for that, you definitely need to have a way from the Python, like from the config, to specify the training task. That would be the one piece of feedback I have. And also, please stop hurting my soul with 2 space tabs. Those are the only 2 pieces of feedback I have. Like, it is actually difficult to visually track what layer of indentation you're at when you have 2 space indents like this. Like, which level does this line up with? I don't know. I guess is it? No, it's this one. Like, see, it's like, yeah. That's all. Cool. I suppose I can just merge this so that you guys have something to work off of. I can do like I will do a speculative YOLO merge. And I mean, this is going to have to go into 4.0 anyways. But I'll merge it into... Where do you have it PR'd to? Yeah, this is kind of my bad because I have not set the PR policies well enough. It really should just be that the PRs come into 4.0. But I think... Do I want to start now or not? I think that it makes sense to just do this. To just, like, merge this. I think that this is covered. Let me just make sure that this is... Wait, how's it 16 files? Drone race, binding. Let me just make sure this is not touching anything that it shouldn't touch. An upgrade, a few weeks. Yeah, so I'll merge this so that you have something to... So people can, like, play with it more easily. And you can get... Because there are some people in the Discord that'll be happy to, like, look at this stuff, provided I merge it. So I'll merge it to make that easier for you. I think what it's going to be is starting in 4.0, the policy is going to be, like, bug fixes only to the current version, and then everything else gets PR'd to the dev version. Fine, this is fine, this is fine. Cool. Clean PR. Thank you, folks. Replace the drone with a puffer. We already have enough environments that do that. Yeah, like this one. Oh yeah, so we have the final results in, guys, from the neural MMO experiment over the weekend. Final results. Here we are. So these are the final results. Cheers, Finn. This actually looks really freaking good when you look at it this way, right? Look at that. I was showing it log scale before. Like this. Blue one is single GPU. So that's expected to be more sample efficient, but that's slow as hell. I don't know why that actually didn't fully run either. But That's slow as hell either way. That's expected, and it's not very exciting. The exciting result is this one, that the new architecture is actually better. Alright, let's see if we can start on our kernel. W times G over R. Does that make sense? It does. Rate of H. Oh no, it doesn't. It fully... See you, Sam. PR for early stopping. Oh, we just got lots of PRs today. Welcome, Kyung. I don't know why I just opened that. Yeah, I really should not have let you do all this stuff to 3-0. They should have all gone to 4-0, but that's on me. Welcome off market. No thresholding. Runs that are below early stop quantile. Increases as cost increase. And let me see how you've done this, to see if this is something I can merge immediately or something I foresee being a problem. What are you doing? This is currently reviewing Kyung's PR for early stopping on our hyperparam sweep, and then afterward fixing the RMS norm gradient for our custom kernel. We have this to figure out and merge, and then we've got this CUDA kernel to develop in the background. Safe zone. Reinforcement learning. I've got lots of content if you're interested on my my X. And I stream all my dev. I'm trying to figure out how you're doing this, Kyung. So after min cost, runs that are below early stop quantile are stopped. What does this mean? Min cost is 600. After 10 minutes, fitting a simple model. Sweep needs data for early stopped runs. Send data when steps greater than 100 mil. Most of my work these days is C, CUDA, unfortunately some C++ and Python. I'm most happy when I'm just writing C, though. Wait, logging threshold is minimum of 20% of the total time steps. So, I mean, this is literally going to be one training step for something like Pong. No, all of our RL stuff is very, very performant. So Puffer is the fastest RL library by about a factor of 1,000. You can literally train these models in seconds on a laptop. And you can run them on a potato. Faster than TinyGrad? TinyGrad is not an RL library. TinyGrad is like a general framework. Nobody has RL code in TinyGrad that is faster than Puffer. Made a PR for adding setup instructions. Oh man, we have lots of PR today. Yes, a 4090 would work fine as well. That's literally what I have on this PC that I'm using here for streaming and for running stuff locally. Most of our GPUs we use for training are 4090s. Hang on. Apparently we're getting tons of PRs today, so let me see. Let me finish this one. Because, Kyung, I'm trying to figure out what you're doing here and whether this is going to work with a bunch of M's or not. What on earth are these questions, man? How should I know? You have lots of time to learn some stuff. Since you're newer, actually, here. Let me link you one useful thing. I do try to help people out who are earlier on and trying to learn stuff. This article here, this has all of my best advice for like general programming as well as ML, and especially how to view science and research and such. It will probably, a lot of the things here will not make sense initially, but this is a very, very good reference point, and this will save you a lot of time. It's a pretty short article as too. Pretty short article. You have a full-time job? This is it, man. I finished my PhD just about 2 years ago, and now I work full-time on high-performance RL. It's all open source, but we also build like high-performance sims for companies as well. Do some contracted R&D and such. I got distracted on this completely. Where'd Kyung go? You're here. Okay, so in that case, I'm trying to figure out what you've done here. This is really, really heuristic hacky, Kyung. Like, I think you're gonna end up cutting off a ton of training runs on a bunch of ends. Like right here, what happens if your score is like percentile, right? You're gonna cut off everything. Like, you're gonna prevent the thing from actually optimizing fully. Like, you've got a ton of little heuristics in here. We do want early stopping, but you've got to do it in a way that's robust. I mean, unless you tell me that you have sweeps on everything and this actually somehow works. Sure, let's chat. Because this will be a great feature if we can do it. The reason I've never done it, though, is it's kind of hard to, like, come up with a good way to do it that doesn't break other stuff. Holy hell, why do I have literally 6 different DMs? Different people. The last, like, hour. Whatever. Here, Puffer voice channel.
Hey.
Hey, Kyung.
Hey, Joseph.
Let me turn your mic way up. Say something?
Yep. Can you hear me?
Yeah, you're good. Okay, so what
can
is
you
this thing?
also share the screen? Because X is
Yes,
laggy. So.
because thing is laggy. Sure.
Ton of heuristics for sure. Yeah, and I've been looking at a lot of breakout runs.
Breakout is like the good, quick environment to test stuff on.
And
I've been trying to get it to be
Tetris,
fast in 4.0 mainly. I've been doing lately.
you know. Wait. Have you shared the screen or you're doing that?
Yeah. Does it work?
Wait, why am I not seeing it?
To click and like click watch or whatever.
Sharing their screen. Okay, got it. All right. Yeah, ton of heuristics, I agree.
Like, this seems
so there are
overtuned to, like, because this will probably work for breakout, right? But, like, this right here, this, so if you do, like, driving, if you ran this on the drive environment, this immediately breaks, right?
so that is the like third layer, the like hard thresholding, right?
Mm-hmm.
So in the like high cost regime, so yeah, like I start that is it. So in drive end, with the score is the like percentile,
Mm-hmm.
right? Like 99%, 99.9% ish.
Mm-hmm.
So so the environments with score that has like either very hard maximum will have no problem doing it and probably benefit from it. But then, yeah, like you mentioned, drive
Because
for
percentile.
those, yeah, like I would. Uh,
Well, I mean, we can think about this. So what are the, can you explain to me the various heuristics? Um, can you explain to me like the various heuristics here?
uh, wait, so heuristics in the
Yeah, so this one is 1.2, 1.2 times cost.
maximum cost, yes. So far, what you have right now is the maximum of the Pareto curve. So that's the almost like the highest ceiling you have seen so far.
Hmm?
The cost to get the highest ceiling you so far, right? And then like you have spent 20% more than that, then like you should be able to at least give me like 5% more on the score. So yes, it will break on the percentile score, but for the other like normal score based, it will I think that will kill a lot of the long runs that just like go doesn't that are not very informative. So for like driving for the driving or like the percentile that like 99% 9% or 99.99 whatever those better, I
Yeah.
think those the scores for those need to be switched like the sigma or something so that like there if you really care about the error rate then yes it should go into like 2 sigma 3 sigma 4 sigma 5 sigma or so forth
Shouldn't this just be
and if
robust?
the score huh?
I mean, or we could have a metric that's more robust so that it doesn't like break on
Yeah,
that.
yeah. I mean that the sigma, right. Like if you go over 99%,
Hmm?
then and if you want to reduce the error further, like 90.9.99, like those won't cut it. You will need to say in time, okay, my error rate is 2 sigma or 3 sigma or 4 sigma, and those will matter a lot and much more informative. So that like in that case, I think score metric should change, not the like that.
Well, that's
And
one
that
potential
heuristic
way,
will
I suppose.
that yeah.
And then what's this one? This is log
Which
of
one?
max of cost in epsilon.
Uh
This is, you put this
the
in the PR to some degree, right?
wait.
This thing?
Uh I'm looking at the figure. Are you showing me the figure?
Yeah, I'm looking at the figure, but I saw this like this log A plus B or whatever.
Log A plus B. Yeah. So the like the cost axis like we are playing in the log space, right?
Hmm?
So the simple quantile regression is fit while X is like log transformed.
So this means, hang on. So this is the safe zone. Okay,
Mhm.
so let me just ask you a bunch of stuff. So first of all, the safe zone here is half of the run, or like what?
So for breakout, that so like that the like a mean load mean cost like that is kind of the like hyperparameter that needs to be tuned for each environment. Like I put it for 10 minutes. For Euro MMO, it might be like 1 hour, 2 hour ish.
Mm,
And like the goal there is to not cut like aggressively too early.
Yeah, it's bad though that we have to introduce these are no longer hyperparameters, right? These are like hyperparameters.
Yes, hyperparameter. Yes.
I think if you ever use the word meta hyperparameter, you're kind of you're not doing so well. You don't want to have meta hyperparameters. Because then what? Do we sweep our sweeps?
Yeah, but so there, that and the quantile-based thresholding, that is like 30, like lower 30% isn't like not too aggressive. Like so, yeah, a Gaussian process needs like some data to get a good estimate. So like aggressive early stopping like leads to bad GP regression that I have observed. So like the safe zone and like low quantile thresholding, those are necessary. Not to be too aggressive.
Can't we just But why is it quantile based on score like this? Can't we just say
Oh,
if you're 30% worse than an existing run then it's bad? Like, can't we do it based on the existing data?
that is being updated on existing data. So in
Oh,
early sweeps, yeah, that is adaptive. So
okay. So
when you
how's it
see
work?
it, so it's just like feeding that like quantile regression every with the given set of data. So in early sweeps, that score will be very low. So there is very little thresholding, but as GP regression gets better
Mm-hmm.
and hyperparameter gets better, the scores, the observation we get gets better. So that the thresholding increases adaptively, but still set to like low 30%.
Okay, so I don't understand how this works then. Let me see.
Yeah, like
Hang on, maybe let me see if brain will function today.
you gotta like you gotta quote write CUDA kernels today, huh?
CUDA kernels, yeah. We're
Okay,
gonna see
so
if we're gonna see if
protein.
we're gonna see if okay.
Now, are you going to switch to Tanigrad if that's good?
I mean, if he can match, so if I write all these kernels and Tinygrad is just like faster out of the box with no downsides, and I just yeah, then totally. Then I'll just
Oh,
be like, hey, Meta, like Google, you guys are morons. Um, this guy just beat your pants off. I even went and wrote my own kernels, and he beat my pants. I will be very, very humble about it. But I highly doubt that happens.
George will be on fire, I guess.
I mean, if that is actually the thing that happens, then but like these companies should just retire already.
Yeah.
I mean, I guess that will fully, in my mind, solidify their place as retirement homes.
Yeah, they can buy a couple. But yeah, going back to you're distracted.
Yes. Why do I open this? Like this is I guess this is just like poisoning my mind. Like I'm just thinking about this constantly. I just open it unconsciously. All right. The LLMs.
So like
I don't say
in
their
protein,
I don't say that their LLMs are bad compared to like how they should be, man. I say that their LLMs are like bad at the task that I'm doing. I actually like LLMs are a way better optimized space in general, and I think that people are doing like overly complicated but generally pretty efficient stuff in that space. All right, so
okay,
this here,
so
max of cost in epsilon, and then it's log. So
mhm.
let me see if I can understand this. So what is epsilon here?
That is just to prevent the numerical error, like
Oh, so it's
when like
actually
a
an
minus
epsilon,
one
like a
or
very small epsilon.
yeah.
Okay, so max of cost. Okay, so it's going to be log cost. Oh, duh,
Mhm,
it's called log C. So it's A
mhm.
plus B log C.
Yeah,
So, and then you're telling me that this looks
like that
okay.
in
So A, so this is A, right? This value is A, and then this shape, this is the log shape.
uh-huh. And you see that the curve is changing, right? So that means whenever every new observation comes in, not every, so new observations are taken into account when that feeding happens, which is when you call suggest. So when GP regression is like being trained again, that's the time that like the log cost curve is updated. So like with every new observation, that log cost model is updated, and as the sweep goes on with better data, that thresholding increases.
Let me see. Where's the thing?
Yeah, like I the in the code in the PufferRL, like that hacky things are to get that curve out. So I wanted to see that like thresholding curve to see if it's working as I intended.
Okay, and then these A and B. Okay, this is where this happened.
Mhm.
Minimize quantile loss. Okay, I see. So, and then the thing is, these should be fit conservatively, shouldn't they?
So that's where the like quantile comes in,
Where's the
and then the
quantile?
loss
Get a
is
quantile loss.
So that quantile loss is like a little bit different from the like standard like mean squared error, and that's where the quantile like from the config comes in, and that's set to like 0.3, like lower 30%.
Lower 30%. Oh,
Yeah,
okay.
that's
So
like
it
a
is. So what this is trying to do is, if you're in the bottom 30% of runs, go away.
go away. Yeah,
Okay, that's perfect.
and
Okay, so then this is
yeah,
actually very
and
good. So what is this doing then? Because like this seems reasonable to me. This does not.
uh-huh. Yeah, so like that's like when you have you have spent 120% more than the like current Pareto like current maximum score,
Hmm?
and then like you haven't still bit it, then go away.
Well, then
Yeah.
why not just make this 1? Or actually, it should be less than 1 because there's going to be noise in that curve.
Uh,
I mean, I could if this were 0.95, I would agree with you completely,
hmm.
right? So if this were
Yeah, yeah.
0.95, we're like we agree that this is like the only way that you filter out good runs with 0.95 with this. Um, well, I guess it depends because when are you using this? Like, how often? Like, are you just applying this every epoch?
What do you mean every
Like,
yeah,
does this?
it's being evaluated every
Okay,
epoch.
so let
Yeah.
me explain something, because this, I don't know if this is you were thinking about this, but your train curves. Okay, so if you're thinking of your train curves as this,
Mhm.
right, or this, or whatever, the train
Mhm.
curves in RL look weird sometimes. You get like this.
Yeah.
Like, then this is all fine. But what happens? Okay, what happens when your train curves look like this?
Jittery.
Which is what you always get, right, when you sample.
Yeah.
And then what happens is you get that the Pareto point is here,
Hmm.
but then, you get a point like this for eval.
Yeah.
It's bad, right?
Okay.
So, and if we go look, I
In that
think that
case,
this would have filtered, like, if we go look at my soda run, obviously, if your thing
Mhm.
is filtering my soda run, it's bad, right? If your hyperparam sweep would filter out a soda run, then it's bad, right?
Yeah.
Okay, let's go look at it. What would have happened here? I'm pretty sure you'll see it. Because this is soda on neural MMO.
Hmm.
You see how much noise there is in these curves?
Yeah.
It's a huge amount of noise, right?
Hmm.
And then what we
Okay.
do is
Yeah.
to get a final evaluation point, we always run extra. Remember?
Hmm.
And actually, look right there with the extra at the end, we get a 9.05. The last eval. But like, this is a big problem because you're not gonna have like an accurate eval, right?
Yeah. I agree.
So you either have to dramatically reduce the sensitivity of this thing, or you have to get a smoothed, like basically you have to do the smoothing in PufferLib so that you get the smoothed curve. And then you're doing it on the smooth curve instead of the raw curve.
Hmm.
Because even with 0.95, you would still filter this run out, right?
Likely. Yes.
Right here, like right here. This would be under 0.95 of this mean value right here. This run would get filtered.
Uh,
Right? Because you look at the bottom
so
of the
wait.
purple zone.
No. Wait. So there, like the reference is, let's say it's your soda run has
Right
the
here.
maximum cost, right? So that like hard thresholding won't kick off until it gets 120% of the maximum you see.
I
So
see. Yes. Okay. Well, then you'll get filtered
so
out, though. Let me think.
so it won't get filtered out until if you are running that for the like same number of times that time steps, and if that run is like not too slow, so that it finishes around like within 120% of the training, then that you won't hit that like that tripwire like.
I think you still hit, like, I mean, if like this is not a sweep, right? Obviously, these runs are way too big to be part of a sweep. This is 650
Mhm.
billion steps. But if they
Yeah.
were part of sweeps, like, you would basically filter any new runs out immediately.
What do you mean?
Okay, this one is like actually soda, so it's like actually appreciably better. But the
Uh-huh.
comparison threshold is going to be the bottom of this zone, the bottom of this purple shaded zone, to the mean right here.
So so there,
This is not
like
smooth.
you that comparison don't happen until you have like spent 120% of the training budget.
Right, but if
It's
you're running a
it's
fresh sweep and all your runs have this amount of variance in them,
mhm.
right? Like if all your runs have this amount of variance, you make it very, very hard to expand to higher cost.
Uh, yes, but like when your initial run has like run long enough, then that becomes the like the and 120% of that cost that duration will be the reference point. So unless the new training runs are being trained until then,
Hmm.
and then yeah, you won't hit that condition.
But you want them to be able to spend more cost to get better, right?
Yes.
Okay, but what I'm saying here is like right now the comparison is already disadvantaged. It's disadvantaged differently for every environment, just purely based off of the variance in the learning curve, right? Different environments, different like batch sizes, they're all going to give you different amounts of variance. And
Mhm.
then what you have is you're saying that that the disadvantaged new run has to be 1.05 max score better. But at 1.05, first of all, like this is impossible for anything that's 0, 1 normalized already. But let's say that we were
Yes.
going to make it 1.0. Even if you make it 1.0, then if you have two curves that are close to each other, and you go past, okay, let's say that this one was only run for 450 billion steps, right? As soon as I start going past it, my run's going to get cut
Mhm.
off because the bottom of this zone, even though I'm better, let alone if it were like a very close difference, right? It would get cut off because the bottom of this zone is less than the mean of this zone.
Yeah, like I agree with you on that. Yes, a 1.5 that is like too strict.
So,
Yes,
I mean,
I agree.
I think that the largest value you would ever want to have here would be like 1. And then the only time you would ever want to have 1 would be if you had like a perfect estimate, right?
Mhm.
If these curves were perfectly smooth, if you just ignore the shaded zones and these were the ground truths, then like I think it works with 1. Um
So let me like take two steps back.
oh,
So
this is
like
also it's 20. Hang on, I misunderstood one thing. I misunderstood. So it's plus 20%. So then the comparison point is going to be from like what, like over here to here, right?
uh so that is the single value. The upper bound is the single value, which is the like the whole
The start.
duration of the SOTA run.
Yeah. So if the soda
It
run
is
ends
not
here, then
okay. Yeah.
then
So
you're going
that
to make
let's
the
say
comparison
SOTA run
here.
runs there. Yeah.
And it's going to be okay. So if there were no noise in your learning curve and you set that coefficient to 1, not 1.05, I agree that this is perfect. Um, because there is noise, I think that this has to be handled. And
Like
I'm trying to think how we handle
point
this.
0.9, like
We
0.9
can do
ish.
0.9 and just hope that there isn't 10% variance, I guess. I think realistically, the best thing would be to kind of be to do both and to just have a smooth score estimate as well.
Uh, yeah. So then the smoothing can be handled within the low cost model. Yeah,
Or it
because
doesn't
it is
have to
getting
be. Hang on, does it have to be smooth or can we just do. Because instead of taking the mean, we get a whole bunch of samples every time, right? So instead of like, well, I guess it depends on the environment. Because sometimes when you get logs, like you don't actually get very many of them, which is why you get this amount of variance. I guess instead of having just a smooth mean, we could just do like a one standard deviation, like a conservative estimate. Like, hey, this run could be as good as this. I think that there should be some type of smoothing or some type of fit, though, so that we ensure that we're not killing off good runs because of this noise. And then you change that coefficient to either 1 or maybe a little lower than 1, and I think it's good.
So there, like the simplest approach would be just like doing running average, like the 50 or 100 data points.
Mm-hmm.
Or is it too arbitrary? Or anyway, or we can get like standard deviation of like the last like 50 or last 100 runs, so that we don't have to keep every like score. And then
Yeah, I think that
yeah,
there's some sort of like not overcomplicate it, but some sort of like basic noise reduction thing that we should do.
mhm.
Definitely, definitely.
Yeah, like so keep the like last 100 data points, get the mean
Mhm.
and standard deviation from there,
Yeah, and then test
and
this on both like really short environments to make sure that like by doing this you haven't screwed up really short running environments like Pong, and then test it on like some more long running environments as well. And then I think it's
yeah,
good.
like that's where like I tested on Tetris, and like Tetris is it seems to work.
Well,
So
Tetris has this like
yeah.
exponential score curve, right?
Oh, not exponential.
Doesn't Tetris like take off all of a
Uh,
sudden and then just go up like mad?
oh, I've normalized it.
Oh,
I tamed it. Yeah, so that the performance is yeah, the maximum is around one, not necessarily one sharp, but yeah. Like yeah, I attached the like Tetris figure on the PR. Have a look.
did I miss that? All right, my bad. Let me see.
That's Tetris. Yeah.
Oh, I thought this was Breakout as well.
Hey,
Uh, the one above that is breakout. So I attached two.
I think that would work very well in population-based learning.
Who's this?
Something like PBT or PB2. It's Brela. I'm just joining in.
Hi.
I've been
Hello.
listening for a while. Hey,
Welcome. You are on stream for reference. Uh,
oh, that's good to know.
okay. This curve. I see. Have this normed. Yeah, yeah. So I was probably only running this portion, Kyung. But when I was running it before, I was only running it for this long here. Like this portion.
Uh,
You can't see my cursor.
yeah.
Uh,
Uh-huh.
like from like up to 600-ish seconds. So it looked exponential to
Hmm.
me because I didn't get the other portion of the curve. Okay.
And score somewhat changed, and the Tetris got difficult. So
Hmm.
now it looks more reasonable to me. So
Okay. I mean, if you have this,
and
then
you see,
no.
uh,
I think that's then the only thing I have right is that at the very least that 1.05 should be 1, and then there should be like some form of smoothing or conservatism on it because it'll filter like that's going to filter way too aggressively. Because basically what you've done here, right, is like so compare. So you have this quantile here.
mhm.
So you draw like, the lower bound. Do I not have the epic pen on here? Oh, whatever. So I thought I had the annotation tool, but anyways, you have like this lower bound, which if you overlap these two graphs, like you're really not filtering very aggressively at all with lower 30%, right?
Right.
And
Yeah.
then you have this really freaking aggressive, like end like better
Yeah.
soda run thing. Yeah, and like that's weird to me because I think that this is basically a free win. This like lower 30%. This is just like
Mhm.
filter out a good chunk of time. And you might even be able to make this a little more aggressive, like, because this is really conservative, right? Like, in my mind, we could filter. Hang on. Heck. Can I just paste images in? Is that a thing? I can. Perfect. Okay, so right now this looks like this.
Yeah.
All right, so like, this could even be, this could even be like a this thing, right? Like you could filter quite a bit more aggressively. But then what you're doing is if I put a point over here, you're gonna filter out anything.
Yeah.
Your filter, I think it goes to like your filter just like goes to here immediately, right? Like plus 20%, and then you have like a hard
No,
cliff.
it's like 5%. Like you spent 20% more, then like give
Okay,
me at least
5%.
5% more.
Okay, but you're
Yeah,
already
like,
above the
that was the
maximum
logic.
perf on this task. And if this
Uh-huh.
were
Yeah.
if this were 0, 1 on like a percentile based task, then you prevent. Yeah. So this is, in my mind, this is just like crazy aggressive.
I
Why do you even
agree,
need? Why do
but
you
like
even need to have these two conditions at all?
because like now when I see the breakout, then like when I see that like 0.9 like 6.97 each runs with 100 seconds, 120 seconds, they drive me crazy. So
I see.
like to me those are like not informative runs.
I see.
So
Okay,
and
so
takes much longer. So yeah, that you have to do something on the high cost regime too. Because
I
once
see
you
what you
have
I see what
already
you were trying
solved
to
the
do.
environment,
Okay, let me think.
I feel like it's more of what do we do with the bad runs? Because if we reuse them and start it from scratch and we are far in the run, it might be having a lot of costs. But if a bunch of these, or all of these, are resumed from some of the currently running runs, then you essentially checkpoints, then you'd have a pretty good performance of
This
the
isn't
run anyways.
population based like that. This is protein, which is Gaussian process based. It uses the same sort of genetic approach on top of it uses a sort of like like Gaussian process guided genetic thing, but it's not the type of algorithm that you just run a ton of different runs in parallel like that. I mean that's really
But
the only like time you really do
even
that
with
is when
not
you're
a lot of
optimizing
runs,
for like really high
right, right.
hardware availability, which is not our main use case.
But even with only a few runs, it would increase efficiency to better utilize these runs that are being thrown out and then restarted from scratch. Um,
Well, we're
I mean,
using these
if
runs
we approach the
to train the Gaussian process.
right, right. So you're using all of the data, not only the final score.
We're using a downsampled version of
downsample
the
it.
training curve.
Yeah,
You
like
get a few
5
points per
data
training curve.
comes out
Yeah.
of.
Is it like 5 data points now, Kyung?
Yeah.
So yeah, you just take 5 points on the learning curve. And I mean it's the same thing because it's the same hypers with the exception of the total time steps.
Time steps.
Yeah, so it
Yeah.
gets a
Time
downsampled
cost.
version of the curve, and that's used to train the GP.
All of these dots are essentially runs.
Yes.
Yes.
It looks quite wasteful. I mean, with a PufferLib is fast, but having that many runs looks very wasteful.
How do you tune like
Yes,
20
but the
hyperparameters?
environment is fast, so
Like how do you tune like 20? I mean, I'm not aware of anything that does like that just can tune a ton of hyperparameters with substantially fewer runs.
I mean, there's no great solution to the problem, but
Like how does
large
this look
environments might
wasteful?
require.
Like I don't have intuition as to how many data points it would take when you have like 20 hyperparameters, right?
Yeah, and it depends also if hyperparameters interact with each other.
Hmm?
Um, like
And
some
some of
tree
them definitely
search
do.
might help with this. Some do. And this is optimizing how many hyperparameters?
Whatever Puffer has,
20-ish.
like 20-ish,
Yeah,
yeah.
20 plus.
20.
And yeah, the 500 is like I ran a like a pretty like large sweep, but normal it's like around 200, and it seems to get us good runs in like 100 runs or so. Like we start to see like pretty good runs after 100 runs.
Right, but we
So
want to
Gaussian
stress test it,
process is
obviously.
pretty good.
I have not found anything better. Like all the PBT based things, the PBT based things kind of like cheat by combining multiple different runs into one on the same plot, and they just use a ton of hardware. Because they just launch a ton of stuff in parallel. Like that fundamentally can't be efficient. You're kind of just doing like intelligent Asha at that point, like asynchronous halving. This is more sequential, so in fact you should require fewer runs, which should be more hardware efficient and less wall clock efficient. In the sense,
Yeah,
like it's going to take
Asha,
longer to run the
Asha,
sweep.
synchronous Asha. Yeah, I know what you mean. But PBT has shown quite great performance when the environment is very long to train.
Well, no, that's because they use
Because
a ton of hardware, right?
um, I mean, even with only a few sample like asynchronous runs, having the ability to come back, like kill a run and then use a checkpoint from another run makes it efficient. But I understand your point of view where
Oh,
the
yeah.
processes, the Bayesian processes, has less data to sample from. So of course you'll get less quality in each new
Mm.
sample. Um,
The other thing I
but I'm
don't
I'm
like
mostly
about
talking about the
PBT,
reuse of the checkpoints.
so you end up creating something where your final model is an artifact of the sweep itself, because you chain together different hyperparameters. If you're going to do the thing where you're restarting checkpoints and setting the hyperparameters, like changing hyperparams mid-run, then your final model becomes an artifact of the sweep rather than something that is easily reproducible, where you can just have your set of hyperparameters and do the full run from scratch. I really don't like that property of it. It's like very, very bad for science.
Yeah, it also means that it biases towards evil.
Mm.
It biases the runs towards evil because it's essentially learning the evil score. So if the evaluation has a different technique or different metric, it's teaching itself. But for some kind of environment like neural MMO, it might create some kind of new SOTA results because of
It could, for sure. I think you'd need a ton of
reusing of,
hardware. Like,
yeah,
the neural MMO result, this is 650 bill.
650 billion steps.
Yes.
Ish.
That's
That is a lot of
13,000
steps.
years of games.
That is a lot of steps.
And consumer GPU, so yeah.
That's 64090s each for those runs.
I read that you're running it on the tiny
Yeah, it got
tiny
it's on the
PCs,
tiny boxes that are up behind me.
tiny box with the 40s or the 50s.
6x4090s. The new ones, the new boxes
That's
they have
impressive.
are 4x5090s, and or the pro one they have is 8x5090. I might get one of those. We'll see.
Yeah, so like sweep is already prohibitive for like Euro MMO. So
The only thing I'm not sure is the
population-based
terminal
running.
behavior here, Kyung. I think that you're kind of right, but like, it just depends on what type of env you have, right? Like, how much do you care about having it fully optimized?
Well, also fully optimized, like I tend to be more interested in the like left side of the Pareto curve, like give
elbow,
me
right?
the good runs as fast as possible. So like those high cost and like saturated runs are like less informative to me. So
Yeah, because if I were to just, so if you were to literally just do, here, you could just do even the simplest fit you could come up with, right? Which is like this. That cuts out probably 80-90% of the training, right?
wait, like what's that curve?
If I just do this,
Yeah.
I cut out like, that's probably half. If I draw it here, I probably cut out like 80-90% of the training time.
Yes.
But then, like,
Like
for Drive, they really care about that. Like, they really care about the terminal, or like the best behavior, right?
Yeah. So there, like I keep saying that, but then like score there really doesn't do good for that kind of optimization. Like you have to have like different score metric to really like drive GP toward the best runs.
Well, okay. Here's an idea, Kyung. Um,
Mhm.
can you link me this plot? Actually, here's the plot that I'd like you to link me if you have it. Can you link me the plot that shows the creation time of the experiment versus the score or the perf?
So it's like color coded there, kind of, but I
Is
will,
it?
yeah,
I
I
see.
will link
Yes.
the.
So, because what I'm thinking here
eh,
is it's possible that maybe we just have it expanding too quickly, right? Like maybe what we can do is we can have it so that it fills in this curve much more consistently, and then it doesn't.
So wait, can you look at the like Tetris curve? So like
Yes.
the one on the, yeah,
This
the
one's way
down,
more
yeah,
obvious,
that,
right?
right. So you need some like time to like GPs need some time to run to come up with like good hyperparameters.
Yeah, so basically what I'm thinking here, Kyung, is maybe we have it expanding too quickly, where
Mhm.
basically, right, we should have it fitting this GP. If it's gonna run bad experiments, stop running bad experiments that take a lot of time,
Yeah,
and like sort of fill this. Like I think it would be cool if over time you kind of just fill this chunk in more consistently, rather than having to run like if you, I guess the thing that's happening right now is if you run 200 experiments here.
Mhm.
Let me show you. I think we're just allocating our compute wrong. Welcome, Hyper. I think we're allocating the compute wrong. So if you run, let's say that you get a Pareto front that looks like, if you run 200 experiments right now, you probably get a Pareto front that looks like this, right? Where it's like
yeah,
a little bit below. And then if you run 500, it looks like this.
yes,
Okay,
it
well,
will move left and up.
yeah.
Yeah.
Well, what we should have is we should get a Pareto front instead. If we run 200, that looks like this. And then if we run
Mhm.
500, we get a Pareto front that looks like that. Maybe.
Yeah, that is ideal.
I guess. Well, it depends, right? What you're trying to do, right? Like, because this gets you a better run faster, but it just wastes so much time. Oh, but wait, actually, we might be able to just have it be strictly better. Because these runs just take so much freaking time.
Yeah.
Wait, is this run? Hang on, let me actually see something. Because you linked me, these plots are after you've already done this early stopping thresholding, right?
Yes.
So yeah, even with this thresholding, it's still wasting all this compute.
And it's much better than before.
Right.
I mean, like, I guess like it will have saved like half of compute already.
Right, and then, but the thing is, the only way that this point even exists here, because this is below this filter, is that it was like, before it knew anything, it was already running super long experiments for some reason.
Yes.
Hmm.
And so that's where the hard stuff like came. Because like the adaptive like quantile based thresholding that increases very slow. But like hard stuff is already there.
Hmm.
So like
Yeah, I see. Because you're trying to basically stop it from running really long experiments before it has any business doing so. Hmm.
yeah.
Which
And
is
at
good.
that time, like the only reference point I have is the Pareto front so far. And like just based on that 120%, like just don't go over that without like a very good reason to do so. So
Well,
it's
I think that if you were to put that at, I think it's probably the issue is it's such a big disconnect right now because this is like super safe in my mind, right? Like this is
yes,
your
it's conservative.
yeah,
Yes,
this is very conservative, but then the other one is super aggressive.
super aggressive, but I, let's see,
And then this safe zone as
aggressive
well.
because
Why like why does it even need a safe zone?
so that's because like I was mainly testing on breakout, which happened so fast, and then
Yeah.
like Gaussian process like that the quantile based thresholding was already like catching like many.
Well, ideally the conservatism should basically let it learn like, hey, the threshold here should be 0.
So yes, like it's mm, you can probably do without safe zone, maybe.
I'm kind of wondering like if this is the good fit in the first place. So quantile based thresholding here. I'm trying to think if we cannot just like, draw our line. Like draw under the Pareto front like this. This becomes the filter.
I tried that. Like I tried to make a filter based on Pareto curve,
It's
and
hard,
then that
right?
was too aggressive. So GP
Yeah.
did not run very well.
Yeah,
So
it's
yeah,
hard because
that's where
anything
I
based on Pareto points, like anything based on just like the individual Pareto points is very sensitive. I found that out when I was developing protein.
yeah. So there like this is like the step back version from that, and that's not I could not mess with GP process. So that's where like the safe zone also came in. So yeah, like
Decent step, I'd say. Um, I mean, I think that this portion here, this is definitely better than what we have now.
which
Um,
portion?
like this, like log quantile, this, where is it? This chunk of the if statement. Where is it? Blah, blah, blah. Where'd it go, man? Alright, this thing. This is
Mhm.
definitely better than what we had before. Or this thing. And then this thing is
Yeah.
super aggressive. But you're saying,
Okay,
but like the thing
so
is that this thing, it's gonna get, because this thing is so conservative, this is gonna, like, if you don't have this thing, you let a bunch of runs through. And like then you let
early,
longer
yeah,
runs through.
yeah, especially during early phase when GP is not that good. So that's kind of like a like safety net. It's not safety
But
net,
it's
but
weird to me
it,
because like, so it will not keep the point, right? It doesn't actually expand the threshold going forward unless the point is Pareto, right, Kyung?
uh, well, it the candidates are sampled from Pareto, yes, but
Yeah.
especially during early, it's not necessarily give us a good results.
Okay, fair.
So that happens like within first
Yeah.
50 runs or so.
Yeah, so basically you end up with this red curve very early. And then the whole curve just gets pushed up over time. But it's very inefficient.
Yeah, it's rising slowly. Yes.
I mean, we could just... The other thing you could play with, I suppose, is... I haven't really played with the expansion rate of protein a bunch. Like, it could be that it's just pushing to longer runs too fast. Oh.
So that's where I'm like
Hmm.
doing Pareto pruning at least.
Wait, but then the other thing is... But, like, what is the first run that you launch? Like, is the default run super long? Because if the default run is super long, then yeah, you're going to get, like, a pretty good starter curve. So you're already going to push your front out.
Yeah, the start is already the default run. So in case of Tetris, that will be around 1200.
Yeah, so it
That
gets already, like, let's say it's this point here.
Mhm.
It'd be, like, a decent default.
Yeah.
Um,
But GP is not that good at that time. So the early 2030 runs will be like very noisy. So you gotta stop them. So that's why you see dark blue dot around like 1400.
well, maybe... Does this thing need to just be more... Wait. Does this thing need to just be more aggressive then? Like this early stop threshold? Because...
The quantile based?
Yeah.
I don't know. Like now we are talking about meta hyperparameters.
Yeah, and this is the annoying bit.
So that yeah, like I'm not too happy with like what I have now, but that's better than what
Oh,
we
this
had before.
portion is definitely better. So this chunk here is definitely better. This portion here has a really obnoxious side effect. I think that if you change this to like 0.9 or a 0.95 and added some smoothing.
Oh yeah. Okay. Yeah. I agree with that. Like that there can be made better.
But this is gonna. I think that doing that is gonna mess up your results on these, because it's gonna let too many runs through, and then the really conservative filter is not gonna catch them.
Oh wait, can you speak? Tell me again.
So because I think what's gonna happen is, I'm gonna tell you to fix this. You're gonna go change this.
Like 0.9.
Yeah.
Yeah.
And then what's gonna happen is that very early on in training, this filter is gonna be too conservative, and it's gonna let runs through that look like this, and then you're gonna get like a bunch of extra wasted points here.
That's the like trade-off you are willing
Well,
to like.
that is the trade-off with the
Yeah.
current model, right?
Yeah.
But hey, I mean, at least you're more aware of this now. Like, we need to have... Like, the good outcome of this is that you get... you do get more expensive runs over time that, like, fine-tune performance. I mean, I think that realistically, even on something like Breakout, right, where you, like... Even on something like Breakout, where you're running these 100-second experiments... all you have to do to prevent that forever, right? So, with like... Okay, maybe with 1.0 or something at the very least. But I think that there's a formulation under which all you have to do to prevent that from happening forever is, let's say that you get one... You just need to get one run that scores... that gets max score, basically. Like, if you get right here, if this at 40 seconds, if you get max score, then everything else after that is nulled, right?
Yeah.
So then anything it tries to run like 20% more than 40, So by 48 seconds, everything 48 seconds or longer gets pruned.
No, so I saw that, and there, like in the code, like I made the max score like does not decrease. It only can increase.
The max score. What do you mean?
So yeah, like when you go to the code, yeah. So like I saw that Pareto can change pretty drastically. So like go to sweep, sweep.py.
Spencer says that self-play hacked the world. See, a second. Where am I looking, Kyung?
Target cost ratio. Yeah, look for target cost ratio. Wait, not it's not target cost ratio. Wait. Yeah, I tweaked that part, but let's see. Upper cost threshold. Yeah, search for upper cost threshold. Yeah, there. So that's the where you draw the line in the sand. And yeah, initially it comes from Pareto front, and then it can only increase but not decrease. Yeah, it's super hacky, but
Why would you do that
that
though?
part also yeah can mess up with GP regression pretty fast. So I wanted to be conservative there.
But wait, why would you? What is this used for?
So that's where the like hard stop gets.
Oh. Lost threshold. I'm confused. Oh.
Yeah, there.
Why would you
That's
not
that.
just use? Why would this? Why would this not just be the cost of the current, like, the current, like highest cost Pareto point?
So like when what I observed is like yes, the Pareto front got like pushed left suddenly, and then I in breakout like I saw there are like a super fast runs. Like have you seen that like solves breakout in like
Yeah, so that's the
20
really
or 25
janky.
seconds?
So that's typically the value function clipping coefficient hack thing, right? Like the really low value function clip.
So there like some of them like it runs like 4 million SPS like
4
and
billion?
like solves break 4 million. Yes, like I have seen like few of them like when things are aligned it seems to be that way, and then it solves breakout in 20 seconds, and then it starts to mess up all the sweep, especially if you set the threshold based on that. So yeah, after seeing that like several times, like I want that like upper like threshold of bound to be like moving slow and like not decrease.
Okay.
Because yeah, it so yes,
I
there are pros, but the con is like it can suddenly start to mess up with GP regression and
it shouldn't
yeah.
well, but this is a threshold that is applied to this is applied like to an online to a run. This is not applied as a filter to the suggestions, right?
It is applied to the run that's running. Yes,
Yeah.
not the filter.
Okay, that's weird then that messes stuff up.
Uh,
Well, the thing that I'm getting concerned about is I think that you could be overfitting the sweep heuristics to like a couple of environments.
yes.
And this is like something I noticed when I was developing protein. Very, very difficult to like, keep in mind that you can have M's that have this like long tail behavior where you really care about the last bit of perf. You have M's where you don't necessarily care about the last bit of perf. Pretty much all M's you're going to care about actually getting a good Pareto front at the very least. I think, yeah, I think that the best thing for you to do with this is first of all, please actually like write out like if you can just put like a bullet point for each like what are the heuristics that you currently have in this thing, and because I would like to know because I think there are a couple things that have slipped by me here, and
Mhm.
yeah, I think then this expansion factor thing, and like how do we deal with like slow expansion to longer and longer runs? That's going to be the key
Yeah.
thing. And it should not be like some complete heuristic hack. Originally when I was developing protein, I wanted to somehow formulate the sweep itself as an optimization problem in which like you're spending budget to gain information, right? And the information you're
Yeah.
gaining is like expanding the sweep, but I couldn't figure out how to do it that way.
That is like very Bayesian thing to do.
Well, yeah, and there's like these acquisition functions which they kind of try to do that with carbs, but then the thing is you actually go look at the Gaussian processes and they're basically pure noise. So like anything, especially the variance estimates, are basically pure noise.
Mhm.
Okay, I think though for the time being, the actionable thing for the time being is this is too aggressive. Make this more conservative so that we know that we're not going to break stuff. Because for reference, Kyung, my goal is in the next couple of weeks, as soon as I have a stable version of Puffer 4, I want to start getting the constellation sweeps in. And
I
ideally,
know.
I want to use the current version of of protein with all your optimizations in there. And if on a couple environments we find something where it clearly breaks, that's fine, and like we can redo experiments. But ideally, I want to have like a very good understanding of what tweaks need to be made, because I want to have and by then we want to have the thing stable, right? Because that's going to be the clearest test of the sweep algorithm as well.
Mhm.
Because like the curves that we get out of that are going to be, we can do like 100,000 experiments on that
Yeah.
as well, and then we definitely
So
want to make sure by
I
then that
know
like
like
it's
it
good.
will save a ton of compute for sure. Yeah.
Yeah, I would definitely say, but we also want to make sure that we don't screw up asymptotic behaviors, right? Like we want to make sure that, for instance, that whatever we're running, we don't have like solves breakout super fast, solves Pong super fast, solves G2048 super fast, but then we go try it and like on the driving results of Constellation, it caps at 99%, right? When that environment, we really
No.
care, right? Like stuff like that. Or like on neural MMO, for instance, because this threshold was applied and there was noise in the curve, neural MMO doesn't do any, like, right? We want to make sure we avoid that stuff as much as possible.
Yeah.
Let me download
So
this.
yeah, like for neural MMO, like if we are to like
Oh, this is
be
hilarious.
wait,
It just juggles the puffer.
yeah, superhuman for sure.
That's insane. Dude, that's insane.
Self-play is like
Holy
getting
shit.
mature, I guess.
Spencer, since you found that, you should put that in an article. That is awesome. Save that for when you release the there should be a self-play blog from that. That's awesome. That's friggin' awesome.
So yeah, so there like €4 MMO
Wait,
it
it
will be
skips.
solvable.
I didn't even catch that.
For
This makes the opponent lose a life? Holy hell.
oh,
I
what
didn't
the
even see that part. Whoa.
why? What happened?
It I
Why?
thought that it just dropped it eventually. No, it somehow it phases the puffer through the wall and it actually makes the opponent lose a life in a way where it's like there's no counterplay. Okay. Huh.
Yeah, so like these agents are really cool, beta testers. They will like test to death.
That's fucking crazy, dude. It doesn't need to come up with this solution to win against the standard Abante bot, yeah. I don't know how it even came up with that. That's nuts.
Bug fix time.
I almost don't want I honestly don't even want to fix that bug. That's like too cool.
Make an the argument to leave it versus fix it. So
I mean, honestly, like putting that one versus the Abranti, versus the scripted bot, and just be like, this is a demo of self play. The self play broke the game in a way that no human would ever find. That's crazy.
yeah,
The superhuman bot
yeah.
has 100% win rate against literally anything. That's crazy. Okay. Anything else, Kyung?
No, but yeah. You keep saying drive, then I keep saying the score metric should be changed for drive.
Well, but isn't it the same for any of the games that have like percentage-based win rate? It
So
would be the same
like
for like Connect 4. It'd be the same for Triple Triad. It'd be the same for chess when we have that, for Go.
so
Just use win rate.
there so can Eero be used instead?
Only if you're assuming that it's a competitive self-play formulation. Anything that has
That's
a
where
solve rate, dude. Like literally anything that has a solve rate. Here, Tower Climb will have this problem too. Right? Anything that has a solve rate will be like percentage-based system.
okay. So there, what's the metric look like there?
Completion rate.
Completion?
Yeah, like did you complete the map? That's the completion rate. And like it has all
Is
sorts of
it?
different maps. They're easy maps and hard maps, right? So if you get 90% completion rate, that's pretty good, but like it actually matters to get higher and higher completion rates. I mean, it's like getting 95 or like 99 on a test almost, right? It's like the last you can't you can't just solve this by trying to reformulate every M to not have percentage based rates. It's like a very common and natural scoring pattern for a lot of different M's.
I see. Then, yeah, probably I will just go for 0.9%, 0.9
That's a good thing to start
on
with for
the
sure.
smoothing metric, and if n have that percentage score base and fine with the longer runs, then yeah. you get well. That's the trade-off you make. Yeah, that's another problem. Let's say that like a sweep cannot handle for now.
For now. There will be a way around this. It's just going to take some work. I got to get back to
Yeah,
fixing these kernels so that we can actually have the speed to do all these things. But yeah, let's keep discussing this over, well, whenever you have time to work on it. Because this is going to be, the sweep stuff is just so important, and I know how fiddly it is because I went through this exact same process of like figuring out, oh shoot, some environments have percentile scoring, some of them have log type curves, some are linear. It's a pain.
Yeah, so like let's leave it that, and I will make a quick fixes that I can do right now, test again, and certainly it will be better than before. So yeah, let's start from there.
Cool. Okay, thanks, Kyung. I will get back to kernel dev. I don't think I
yeah.
have any more PRs to look at right now.
I have
Alright,
fun.
see ya.
CUDA
Thanks, Kyung.
mining.
Back to the CUDA mines. That's cool. Oops. I don't really want the laziness or the functional nature necessarily, but if it's fast, it's fast. So we will see. Where? Use Keras with the Jax backend. No. Alright, let me grab a refill on my coffee. Let me use the restroom real quick, and then we will get back to this ridiculous CUDA kernel for what is a very simple operation that has a really obnoxious gradient. I'll be right back. Well, let me turn the new flag lights on because they're kind of cool in the spotlight. We got these installed over the weekend. Much better, right? Freaking Discord messages. Make sure there's nothing I have to answer right away. Okay. All right. Get the desktop audio again and figure out why gradient is wrong. Okay, so this is element-wise everything. And base is, where do you run your GPUs? Keeps the warrant literally right there. Oops. You see them all? Two tiny boxes, bunch of individual boxes. They're all right behind me. This is the puffer training facility. Out of index. Okay, gradient out index times inverse RMS, right? Minus wait. Grad weight wait, the gradient with respect to the weight is just this, right? And then you get base plus h, because I need to do dot product. But wait, how does this make sense? So I think we just do float wg dot x, wgx equals 0. Okay, and then we just do float WGX equals W G add X times this, right? I still see templates. For now, man. For now. Probably will be eliminated. It kind of depends, because literally all you're saving with these templates, I believe, is you're saving like 2 casts. You're not even saving the cast. I think you're saving 2 copies, maybe? Might be worth it, we'll see. Okay, so, yeah, this does not work. X, EXI, XIS, what is S? Yeah, Discord's discord.gg/puffer. Presumably this is the weight. Missing division by H. That would be completely stupid, wouldn't it? Also, your indexing is completely broken. Well, that's expected. Divided by h. Float. This. Add weight. This is not, yeah, this is fine. I don't think this is... reduction inside the block. Oh yeah, okay. Yeah, the weight Akim is wrong completely. I'm gonna just try this out of the box to see if this does anything. I'm not particularly hopeful, but this is a fairly common kernel. Oh yeah, let's try this one first. This is the slow version. Try the slow version first. This will not surprise me, actually, if this one is correct, because... yeah, this one would not surprise me if this one is correct. This is a very common operation. Backward kernel. The block per vector version above. Something is ungodly slow. Wrong. Did it change my signature without Brad? Not have EPS. Stupid things should not change my function signatures. Okay, this actually does look closer. No atomic add. That's just, that's an include missing, right? You know which one should be the starting point. You are never going to catch up with the number of streams I do, so you should probably just watch the live ones. And if you're looking for formal material, then you should check my guides here. Like, if you're looking for something to work through, the best use of your time is, depending if you're very new, this one, or if you're just looking for RL, like, working through this will be the best use of time. And other than that, you just watch the, whatever is currently the live stream. Because that's what I'm doing at the moment. These are not, like, produced pieces of content, right? These are just, this is what I'm doing on a day-to-day basis for dev for Puffer. Yeah, that's crazy obnoxious. Want to get something to hack on? Yeah, the guide will take you through that. Convert, I've created a fanatic. My gosh. Does this make sense? Reinterpret cast. And float star. I actually don't know if this one is fine, but it should not screw up our test either way for a kernel we don't even know is correct. So let's not spend more time on it until we actually know whether this is even any good. It seems weird to me that epsilon doesn't show up somewhere in the gradient as well, right? Oh, maybe it does actually, because it's... Yeah, you have the cached inverse RMS term. So probably that's it. It is much closer, but it is still wrong. And just for the hell of it. Yeah, just for the hell of it, let's try this one. Yeah, this has... Don't you need to include, include warp, reduce, yeah. Eh? Isn't it included? Am I stupid? Oh, does that not even exist? Okay, let's ignore that then. And let's see if I can understand in the meantime. If I want to contribute to PufferLib any ML related math, what I'm doing here at the moment is I am mostly failing to remember my CS231N. You pretty much just follow the RL guide on Twitter. It has, like, my RL guide will take you through all of the things that you need, and it will direct you to everything you need as well. So I guess that one's probably in... This one's in programming and ML, yeah, because it assumes as a prereq. Where's T231N? Yeah, Stanford's 231N. Literally between these two blog posts, though, you have all my best advice. Huh? What happened to warp? Oh. This is saying that I missed weight, grad out, inverse R mass. Wait, weight, grad out, invar mass, float, weight, h. And we will see. Well, that doesn't help now, does it? I don't think that was supposed to be there either, right? Let me go see. Grad index. Yeah. That was the original. W, G, invar mass minus X sum inverse over H. I actually don't see this over H though, do you? I don't see where this over H, hang on. Let me try something. I wouldn't be surprised that it ends up being this stupid thing. Because I don't think there is a division by H there. I actually don't see how there could be. Okay, yeah, no, that produces massive grad. So there is gotta be, either there's a division by H or something is missed, which is like the worst nightmare situation, because now it's like I don't know if the math is wrong or the code is wrong. Add weight. Float, grad out. X, then weight, grad out, float. Weight, grad out, invar mass. Yeah, so it's the same. Grad X minus E. Missing division by H. Oh. Where did it give me the gradient? SRMS? That maybe I misinterpreted the original. Ah, hang on. Because this is one over n sum I XW. Yeah, there's definitely no division by H in here. With respect to X at least. And yeah, so this is no longer a code problem, this is a math problem. I don't know why I didn't think of using like auto diff on the or symbolic diff. So what does this give me? 2? Okay, let me see what was different here. So oh, it's completely different here, isn't it? Or is it not? On RMS. Try something. What is the difference between these two? Let me run it first to actually, because it's not worth wasting time if it's wrong, right? So let me see if the math is mathing. And I also have to fix this chunk here. Here, still 0.2 off. Which is like even closer. Still off by 0.2. Okay. Let's go back to this and let's actually try to understand the math. Because I think at this point, it is mostly a question of the math. So wait, let me go look at the symbolic version here. Sum of 2ai, 2 times n equals, we have 2ai over 2n. This is RMS, equals ai over n RMS. Suggestion. I'm trying to figure out what the heck is wrong. If it's the math, because it could be that the math, like, it could just be that the math is wrong, not the implementation, right? It's like not there's like not a bug with the code. It's just I'm implementing the wrong thing. Man, if I could just find gradient. They have the gradient in this, I wonder. Presumably not. Gradient with respect to the weights. Ugh. How's there a weight matrix? It should be a weight vector. This is honestly what I would want. Presumably this is not open source. Video transformer engine. I think these functions call each other. That would make sense to me. That's norm. Oh, here it is. PufferLib's got platform. I had no idea, man. You can try it. Where is the implementation? This is what I want, is they actually have kernels for this shit. Former PyTorch distributed. I would really like to find the code for this if I can. Add. I'm just like confused. Where the heck? Ah. Ay, 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 look at all these. Launch general. Okay, so these are just the launchers. Semi-cute, what? Is this it? I think so, right? Isn't this the actual kernel? Eight. Cute variants, what? Times diff, all reduce, sum. Oh yeah, yeah, this is. Okay, so for it's in the CUDA H file for some reason. So it stands to reason that this one would be in here. Now the question is, are we actually going to be able to figure out the math from this? Yeah, this is a hell of a kernel. So I mean, we found the code, but like holy hell. Is it still here, or is it just above? Yeah, someone had exactly, right? It's like, well, shit. You know, I'm honestly thinking going forward, I'm learning so much by doing this, though, right? Because if this is the level of engineering it takes, like, if this is the level of engineering it takes to make an RMS norm fast or whatever, like, here. Do you think that the people who wrote this were thinking, like, at all about actually implementing this operation to be fast? No. They were writing, like, a few lines of PyTorch and just testing different shit out. So, like, if you actually approach architecture design from the sense of, like, well, what is easy for us to make super fast? And then, you know, you kind of realize that a lot of architectures end up doing very similarly when matched in flops. You can probably get very, very far just by understanding that, right? And I did not have a big enough appreciation for this because I forgot about the horror that cross terms introduce and stuff like that, right? Like, yeah, any sets of, like, element-wise gates or whatever, not a huge deal. Those are pretty easy kernels to write. But anything that's going to introduce cross terms like this, you'd better have a damn good reason for doing. Right? Because if this were not in something introducing cross terms, right? If this were just like element-wise divide by, I don't know, square root or something, that's an easy kernel, right? And then also this introduces additional synchronization requirements. Like, I'm honestly wondering if, like, I should do some architecture work after this because, like, I don't know, can we just, like, I want to go read that, like, that tiny recurrent network paper or whatever. I don't know, can you just, like, come up with some matrix multiply based, very easy to implement, very intensive, like, operations with some nonlinearities? I don't know. Because basically all you're trying to do is come up with, like, some arithmetically intensive, expressive operations that are easy to implement, right? Most of deep learning just boils down to you're doing some matmols with some nonlinearities in one way or another. And, like, the researchers are never thinking about this at all, right? The researchers are comparing metrics that frankly don't even matter that much most of the time. Right? Like, whoop did you do? Your thing converges in 20% fewer steps, but is going to be a complete and utter nightmare to implement to be anywhere near, you know, within 20% of the speed of the other one. It'll probably be 10% of the speed of the other one. Jess, this is the crazy kernel NVIDIA has for RMS norm backwards. Matrix math. Yes, so matrix math is always the best option because the chips are designed to do matmols. Like, that's all the tensor cores do, is they do matmols. So as soon as you're not doing matmols, the hardware no longer helps you at all. Quick question, why? Because we need RMS norm to not be slow. Well, here is dx. Can I just figure it out from this? Like, compute dx, dy, ij. It's so freaking hard to even figure out the math from this, though, dude. Why is their kernel so whack? Well, some of it is understandable because, like, there are multiple synchronization points to do this thing fast. And I think they're supporting, like, too many things in one piece of code. Like, I think this technically supports a fused add with it as well. Finalized tuned. I literally just need the gradient written out for me. That's the annoying thing about this. I can't use this easily, right? I don't think there's any way for me to easily use this. Oops. I guess. I believe this was 0.2. I can just get a working version, I can optimize the hell out of it. And I actually want to know, like, the naive kernel. I want to know how it compares to torches. Add. Completely wrong, right? Completely wrong. Okay. Go back to this. We just need to be precise about this thing. Like, there's some very small math error, most likely. Thank Young. I have the forward pass correct. The forward pass did not take very long. Let me see if I give it the, because, you know, it probably is going to just keep doing the math wrong, but maybe it can pull out the math from this. Let me make sure I get it the right one, though. This doesn't look like it has the math in it, right? This is... What the heck is this, then? RMS norm, backward general kernel. Yes, this actually has the implementation in it. Finalize. GP regressions on scores, uniform space. Actually, GP regressions on score. Is it on uniform space? That doesn't seem correct to me, man. It would not work at all if we were doing uniform. Unless is it scaled, as it could be scaled uniform space, right? Cost is log. Scaled, okay. I think I experimented with that already though, Kyung. Because the issue is, it's not, you don't want log scale, right, for the percentiles, you want logit scale, and you don't want to have to, like, configure that. Final answer. So, like, insistent and annoying. This I wouldn't be surprised if it's able to get right now, because I've given it the NVIDIA kernel, so it's literally just having to, like, meticulously pull out logic. And if this isn't right, then we're going to start looking at other stuff. Like, did I populate buffers correctly? Oop. Comic add. Float star. Cool. Let's try this. It's like slightly closer still. Okay, let me go look at the forward pass buffers. But the only thing we store is this, right? Inv norm buff, float. I don't see how we could possibly be messing this one up. Why do we only have one failure? Hang on. Okay, so I mean, they're both freaking wrong now. Right? Both the grads are wrong. The forward pass is correct. Extra sweep arc to specify. Yeah, I was gonna do that before, man. Ideally, you really don't want to have to do that, but... Because it's like... Have you ever tried training enduro? In enduro, it just goes... The curve just goes straight up. And, like, it's literally... It goes up faster with fewer environments, because it's just... You solve it very quickly. And it's just a matter of how quickly you can run the environment to get more score. Oh, this one doesn't even bother with the... Yeah, okay, this model's just stupid, I swear. I don't know why it's like... It's like every bloody time I try to check, like, try to use the model, it's like... Every fucking time. Like, maybe this time it won't waste my time, and it's like, yep, nope. Maybe next time. It's so stupid. Okay, this was my original kernel. Honestly, Habib, I have no idea. All the models kind of suck. It saves me time when I use it as fuzzy docs. It wastes my time every time I try to get it to do something. It's literally a meme in this chat that people just post their favorite LLMs, and then it fails to solve whatever basic task I'm trying to do. Every bloody time. Okay, well this gives us something. Now I want to check, there are a couple things I want to check. I want to check first of all if this one has the gradient with respect to weights correct. Because that's a very easy gradient, isn't it? If it's not a very easy gradient, then I have something fundamentally... I'm like fundamentally misunderstanding something about the problem. this actually. Huh. Okay, so both gradients are totally wrong in both implementations. I don't know what to do about this, guys, because we need an RMS norm kernel in order to be able to freaking ship this update. And this kernel's apparently ass. Yeah, both the weights and the... I mean, it's like I don't even have the freaking analytical gradient for this thing. Apparently, it's more complicated than I thought. No, forward pass is correct. Forward pass is trivial. Launches 3 different kernels. Alright, I need a break from this or I'm gonna go fucking insane. So, I guess what I'm gonna do for right now is I'm gonna see if I can fix Peru's threading thing so we can at least get an end-to-end profile speed. This is just like... Dude, why do we use these operations if they're this shit? Holy hell. I think. RMS norm. Let's go figure out Peru's threading thing. Peru sent me a threading thing on X, I believe. So let's go find that. That's like so incredibly obnoxious, man. How's wrong with this? Huh? Not the real error. Yeah. Bullshit. I'm gonna set myself aside some time later this week to just play with this thing. If this thing will output kernels. We will see. Has not been declared. Dude, what did I fuck up with the network def? Eh. Like something stupid just like got moved or something. Oh, you know what it is? It's this stupid thing. Is it not this? How did I get some awful... How did I do this? Like, nothing wrong with this. And somehow we broke the entire compilation? How did this get fucking broken by shitty RMS norm? This is now the correct one. Maybe this is conflicting with the torch namespace. I think it should be, though. This will give me a better error. But like, I mean, this is just so. Oh my god, are you shitting me, dude? Are you actually shitting me? Like, this gets parsed into that, really? Fucking terrible language. If you're developing on Windows and you're not at least using WSL, you're just trolling, you don't know what you're doing. For this type of stuff, nobody serious does their dev on Windows. 0 people. Okay. I hate C++. That's like disgusting. This language sucks. We don't need this. We just need this runs. Is it really not train? Oh, actually, hang on. I know why it doesn't train. It's fine. It actually trains a little bit, which is kind of interesting. I didn't realize it trains like a little bit. Actually, like surprisingly decent. But this is not the yeah, there's still a gap. But at least we know the grads are right. Oops. Let me go find Peru's DM. I already had it up on the other window. Fuck is that? Yeah, I found Peru's message. $6 mil. 8 threads. Done is enclosed in a one loop that will always hold the lock. Yeah, so evidently this thing needs... Yeah, so this is deadlocked. He did here. Done is enclosed in a while loop that will always hold the lock. Done is enclosed in a while loop that will always hold the lock. Is this it? Infect step. Yeah, so I think Okay, well, this does not break for now. Cool. Is this still broken, though? Yeah, it's still freaking broken. God damn. Okay, 3.1 mil. So, we basically need to figure out what the heck happened to performance then. And actually, let's just, real quick, even though this is not super stable, because we're not even in the right ballpark right now. So let's fix this first. Let me get my coffee as well. Holy hell. I'm gonna do one quick lift to wake up. Puffy. Okay. So, train speed, 3 mil. Let's see if this will tell us what I have massively screwed up. Okay, so CUDA time total. It's like a long tail of different shit, isn't there? CPU time and CUDA time. Let me see. There's full step. This does not show any CPU time. This shows a bunch of CUDA overhead. And then, where's the CPU time coming from then? I think based on these replies, I will at least put in some amount of effort to this before I do another round of fucking with that kernel. At the very least. Okay, so... okay, I see. It's because of the way it's sorted. Cool. So we've got two profiles here. Alright. This will be good data. So we've got two basically identical profiles. I'll put it as best as I can without covering everything. You see that these are pretty much the same amount of time. You know, if TinyGrad has gotten good to the point where, like, we can just swap it and it solves my problems, I'm very willing to do that. Now, my hope is that there is the flexibility to write your own kernels. Or at least, you know, maybe the way we use it is that TinyGrad will output a kernel for us. I don't know if it'll output a, like, well-written kernel or whatever, but if I can get it to output a kernel that is correct, that I can then manually tune, that's also acceptable. Getting the gradients right manually for some of these operations is just so fucking hard. Like, the actual programming portion of this, like, sure, okay, I haven't done, like, warp synchronization, or even, like, I haven't done, like, any, like, basic block reduce or anything in CUDA. That doesn't concern me. That shit is not hard to figure out, okay? Like, parallelism just is not that complicated. And getting the gradients to really fiddly operations, fucking hell, that's a pain. Okay, so we have here 1.1 second CPU and 400 ms CUDA. Now we're going to figure out where this stuff comes from. Interesting. So I don't understand these overhead operations. I do see, though, the massive amount of CPU overhead time we have here spent on syncing CUDA streams and launching kernels. Now, the thing I don't understand, right, is this not including... Here, if we add up these numbers, 4, 6, 7, 8, it only gets us to like 900 ms CPU time, right? So these don't match. Okay, so we're getting just CPU bottleneck to hell anyways. Cool. Let me see if I can figure out a few other things. This is actually for 5 steps. Get first step. You want I'm gonna go check the torch docs instead of this. Profile. Skip the first step. Start warming up on the second. Fourth. Okay. Don't need this trace. Okay. I did not require all of that bullshit, thank you. Actually, remove fence shapes, mem, base. It's fine. Cool. Okay, we shall see. We shall see what this does. We'll see if the totals make sense. Yeah, it's taking forever to jump the averages. CPU time, CUDA time. One 1.7, 3.9. Was it 4.486? So then what do we have? 8192 times 4 divided by this. 7 mil. Okay, that's literally impossible that it's this. Oh wait, average. Yeah, so it is supposed to be average. So we just take full step time. Hang on, I think this one should match, right? So it's 1.76 plus 0.9, 3.9 mil. Too high. 9.6. That's a lot closer. Plus 5. This is 2 mil. Yeah, and you sort by totals because, yeah, okay, that's fine. So, yeah, this is ridiculous, right? That's freaking crazy, though. Okay. Figure out what the fuck is going on here. Okay, so let's comment this stream sync. That's all we have. There are no synchronizes. Figuring out why shit is so slow, Jess. New update. Hello, Spencer. I hope you're having a better time than I am here. Online PPO against Abranti does find the bug enough time steps. Self-play converts to the same optimal strategy. That's cool. That's very cool. Hey, I mean, you definitely have it working if you have that working off of self-play. Now you can actually, that is a simple environment that you can ablate. I mean, you know, the dynamics can be more different in a more complex end, but that's a really nice one to ablate to see, like, you know, how many historical opponents do you need and stuff like that. Do you need any? Etc., etc. I am fighting demons, my guy. I am fighting many demons. Honestly, Spencer, you could probably try. I have no idea what types of behaviors you can get out of MOBA at all. I hope the animations are good enough for you to be able to, like, tell if stuff smart stuff is going on as well. But hey, if you get an elo curve that's, like, smooth and, like, keeps learning stuff, MOBA, chess, like, there are a lot of M's that you can do it on. I'm just gonna be fighting Perf for a while, man. It's tough. It's really obnoxious. Elo looks whack because both players end up cheating. And that's just who gets the ball more. Well, presumably there's a curve until then. Right? Or no? Yeah, there it is, and it falls off steeply. Yeah, so I don't know how shouldn't fall off once it finds that strat though. There might be some weird quirk of Elo with that. Try on other M's. That is great news. That is great news. So I have lots of good kernel optimizations, but there's like a ton of CPU overhead that I'm currently tracking down. I also don't have a good RMS norm kernel yet, but apparently this is more of a pressing issue anyways. Probably there's one in the .cpu. Every single iteration. Okay, so that is 64. 64 times 20. No, I don't have a step. I can double check, obviously. Like, can I just do real quick, I just comment this whole block? Hey, Finn. I think it's very appropriate that we get our first intern is named Finn. That's very appropriate. This is way faster, admittedly. If Spencer can get it done in time, which I think that Spencer, you're gonna have plenty of time because this stuff is like, this is brutal. I don't think there's any way I get this done by end of year. I'm gonna work as much as I can, but it's like, the good news is, I think if I do manage to get this done regardless, like Puffer 5 is a much more self-contained thing. So a lot easier. I think infra-wise, it's not that bad either. Uh, uh. Who does stream synchronize? Cool. Glad to be part of Puffer. Puff Puff. How easy will it be to merge? Jess, I have no idea. I'm gonna make this shit easier, but it's gonna get harder before it gets easier. We will see whether I've screwed up in my kernels. I don't know where I would have, for syncs at least. Oh, that didn't help. Well, let me make sure it's even from the forward pass. Make sure that this is actually going on here. I don't know if this will actually work or if this will just crash, but... That's so funny. Okay, so it is in the forward pass somewhere, you see? It's in the forward pass. Try this one. I mean, it's in the compiled eval at least. The puffer will be fast. What the fuck does this even mean? Serious issue. Correctness is a serious issue. Interesting. Okay, so it is actually... It's synchronizing a shit ton for some reason. Towards zeros. And the easier thing would just be to synchronize. This is, at the moment, this is getting rid of CPU overhead. So optimizing CPU overhead plus good kernel should give us 10 mil. But like Torch just does utterly stupid shit all the time for no reason. Basically, I don't know which of these ops do this shit. Well, we should probably just, like... There's a lot easier way to test this shit. Freaking PyTorch, man. Okay, that did nothing. Good job. Literally nothing. faster. Okay, so they're all in the forward pass. Brock is stupid. They're all in the friggin' forward pass somewhere. Does torch check sync? I mean, that would be insane, right? I'm here, like, looking. Ooh. I think I found it, but... Yeah, I think I found it. This could do it, right? Almost exactly. This one's better. No, actually, I like this. Implicit copying without telling me is so evil. I mean, implicit synchronize without telling me is so evil. Is it seriously this? $6,280. Is it not this? We'll see if this does it. Learn programmer coding. If you are interested in it, so if this does not change perf, where else would it even be? Yeah, so it's not here. Clearly. Let's take dim. No, so can I just return X? Can I just do this? No op. Well, you don't learn cybersecurity without learning programming. I mean, this is obviously faster because we've no-opt it, but, ridiculous overhead. Which profile just takes forever as well with these settings. I'm gonna change it actually because it's just like unbearable. Oops. 20. doesn't make any sense, does it? This should be 35. 5. Profile is just so stupid. How is it taking this long? Does it hang? Times 5 times 4 is exactly the same as before, right? Yeah, times 4. Exactly the same number of calls. Was this 1500 something? That's bizarre. You know, the thing that just sucks about this type of work is you can work all day and get nothing, like, you can actually make no meaningful progress. It's ridiculous. Nothing will burn you out quicker than working on stuff, like, all day and not making any meaningful progress. Ugh. Okay, so it's not the Mingru somehow. Literally, that doesn't even make sense. Yeah, I mean, you learn stuff, but you learn, like, bullshit that shouldn't exist. Still 15-7. How? Dude, like, how? Should be 0 synchronizations for fuck's sake. Okay, so it is this. Okay. I swear I profiled that before, but whatever, I guess. Okay, it's still 610. So let's see if I can guess. Might have to make these non-blocking. That's 1250, right? This also does it. Still 1250. Weird, isn't it? Two synchronizes in here, isn't there? Let me see if this rises predictably. Debug loop is so obnoxiously slow. It's just doing way too many synchronized operations, and I don't understand why. Okay, so 290. And then let's see. Does this rise predictably? From 290. Two ninety to 610. To 610. Okay. This is predictable. I assert that to here it should still be 610. And these buffers as well. Oh, hang on. I'm just giga dumb. Ten. Now these are on GPU. 610. I bet you this is just like moving devices and I'm being stupid. You are an idiot. Ha 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 ha. Chess MVP like kicks rocks, entropy collapse. One kicks rocks, best model yet. Yeah, man, this is why we want like stable regions. This is one of the things Constellation is meant to fix. Material reward shaping has been good. Added that back in. Good. Fuel. Need to train more. You can run some stuff on the boxes for a bit if you have stuff ready to go. Literally just forgotten on blocking. Total doofus. Okay, this is the expected 610. Now this should go up by what, 320? Live source is pinned. 9:30. It was 6:10, not 6:10. This is good. So the only sinks now, we got rid of these. Final draft ends of Thanksgiving. Cool. If you have stuff to run, I have like, you can just run, make a boxes behind me. We can run some stuff. Would you contract someone specialized? We do contract for client work. Like, I make zero money directly off of this. This is all open source. So the only revenue we get is from client work directly, and then we do bring people in on that. It is pretty much only people who I've worked with directly and have been doing stuff around Puffer. Oh. Alright, I hate this stupid thing, but whatever. That should kill a couple sinks. And then if I get the synchronizations down to just the ones that we need for env, then we'll basically know the exact overhead of env copying around. This should remove 16, I think. No, way more than 16. 16 times like 64. Oh, we'll see. Yeah. Down to 850. So there are just a few more of these in here somewhere. I mean, these are a couple, but these don't really do much. There are no things that should synchronize. Trace. Okay. I see no things that should synchronize here. 850. The dot items are obvious. Yeah, this does it. Cool. Hmm? Oh. Well, yeah, this has to get synced. I think I screwed this up, man. Duh. Wait, no, that shouldn't cause a... With the replacement. What? Yeah, this is not fast, you dummy. What if I sample without replacement? See if it changes. I think this probably breaks, no? Fuck, wouldn't it be thread safe? I gotta go get dinner in a second. I want to understand this. Is this thing hanging? God damn. Nope, still 850. Good job, Torture. You very or Grok, you very stupid. Well, I wonder if I do this. Comment my entire loop. Welcome. Yeesh. See if this is still 650 or 850 sinks. $690. Okay, so 690 sinks. Let me see. 850 690. I don't know why I do that. 170. Let's see. 170 by 16 divided by 5. Can't be by 16 then, can it? Should be 16 mini batches. I think that there are probably 2 synchronizations in there. 960. We're at 690. Correct number. Oh, wait, which is the correct number, right? Hang on. Am I wrong or isn't that the right number? I swear if it's my optimizer somehow. Okay. That wouldn't make any sense. I think it's just making shit up on me now. What do you guys think? I mean, this is very easy for us to just fuse the clip into the optimizer, right? If it is. In fact, this would be the easiest one. And damn, it is synchronizing. But actually, there's more than that that's synchronizing as well. That's annoying. Syncs are here without this 690 with all 50. What were we expecting again? So it was 64 times 2, 40. Ah, so then yeah, that's pretty close. Okay. Well, I gotta go get dinner, folks. Thank you for tuning in. I think I got some client work that I gotta do after this. I can't just be working on the open source stuff all the time. So I'm gonna do that, and then I'm gonna try to get some longer hours in this week, honestly, because that's what it's gonna take to get this thing shipped. There's just so much perf optimization to do. Like, this has at least gone down a lot, right? What are we at now? So CPU time average. This is still awful. This is still awful. So all these syncs are killing us. These kernel launches. This will be handled through Fusion, though. And then we got to figure out what the heck is up with, like, the Matmul CPU overhead. That's weird. There are, like, a few things we got to deal with here. But, yeah, I think... I mean, the good news is, even with this... This is 3 mil. I'm pretty sure... Like, literally, this means just if we cut some CPU overhead, we're at 10 mil. Let alone, like, the fact that we're The optimizations are literally this overhead is ridiculous. Anyways, though, thank you, folks. If you want to help me out for absolutely free, Puffer.ai, star the Puffer, feed him a star. He likes stars. Join Discord if you want to get involved. Follow on X for more content, including my education.